It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 6, unit 6 here, where we're actually going to jump in with lesson 2 to start off today. So notice we're at lesson 2, we'll be doing lesson 1 together. So we're going to solve systems of equations with substitution, and technically this lesson is review from 8th grade, in which you already learned how to solve systems of equations with substitution. So we're actually going to skip the opening exercise and jump here to number 1. So this whole unit has to deal with solving systems. So when we solve a system, we're looking at two variables, x and y in this case, and notice it's equations plural, meaning I have two equations. So I have two linear equations here. I have y equals 7x minus 2 and 2y minus 4x equals 10. And my goal here is to solve this system of equations by using substitution. So here's what we do is we need to find one of the variables that's alone. So our first step is to find a variable that's alone. So notice here I've got y all by itself. And what does this mathematical statement say? Well, it says y is 7x minus 2. So down in this equation, wherever I see a y, what can I replace it with? Well, y is, I can substitute wherever I see a y with 7x minus 2. So 2y, right? 2y minus 4x equals 10. I picked up what y equals and plugged it in. So now I need to solve this equation, a little distributing. It's been a while since we solved something actually. Minus 4x equals 10. Combine like terms since those are on the same side. I'm going to add 4 to both sides, and I get 10x equals 14. So when I divide by 10, you're all panicking right now, but that gives me 1.4. X equals 1.4 is the value of x. But when we solve a system of equations, I want to know the point of intersection of these two lines. That's what we're solving graphically here. Where do these two lines intersect? So I take my answer and I plug it back into one of the two equations. So y equals 7x minus 2. Y equals 7x minus 2. So y equals 9.8 minus 2, which is 7.8. I believe so. It's late at night here and I'm making this video, so I'm going to go with that. Where do these 2 points intersect? They intersect at the point 1.4, comma 7.8. That's where these two lines intersect. So I found one of the variables alone. I plugged it in for y and solved from there. So we're going to practice a couple here and see what happens. Solve the following systems of equations using substitution. So I see here, y is all by itself. That's what y equals. Y is 5x minus 19. They're equivalent. They look different, but they're really the same thing. So down in this second equation, wherever I see y, I'm replacing it with 5x minus 19. Y. That was my substitution there. So now I solve. Now I solve this, or there's a couple ways to solve it, but I'm going to subtract 3x. I hope your equation solving skills are all brushed up on here. I got to get x by itself, so 30 equals 2x. Well, what times 2 gives me 30? Well, that would be 15 equals x. But I haven't finished solving the system yet. That's the x value I've got to plug back in to get y. So y is 5x minus 19. So type this into a calculator. 75 minus 19 is 56. So where do they intersect? X comma y. That's the point of intersection. That's the solution to the system of equations. All right, sliding on over here. All right, I'm looking for any variable that's oh, there it is. X is all by itself. It's all alone. So wherever I see an X, I can really replace that with 2 minus Y. Wherever I see an X, I can replace that with 2 minus Y. So 12 minus 3X equals 3Y. And then I'm going to distribute here. 12 minus 6. Careful, it's a negative 3 that I'm distributing here. Plus 3y, right? Two negatives multiply to a positive equals 3y. So combining my like terms, I get 6 plus 3y equals 3y, which is weird because when I subtract 3y, I get 6 equals 0. So what that tells me, this is not true. This tells me there are no solutions to this system. There are no solutions to this system of equations here because I got a false statement. You hear Willow barking in the background. She's angry. She doesn't get to be part of this lesson. So sometimes when we solve a system of equations, we don't get a point of intersection and there's no solution. All right, sliding down here. Again, I'm looking for the variable that's all by itself. Bam, there it is. Y is 8x minus 1. So wherever I see a y, that's what I'm going to substitute it with. So 8x plus 5y, even though it's not really y, I'm replacing y with 8x minus 1. So I'm going to distribute here. 8x plus 40x minus 5 equals 19. I got to solve for x. Same side. These are on the... Did I do this right? I did. We're good. I get 48x minus 5 equals 19. Well, I want to get x by itself, so I'm going to add 5 to both sides. So 48x equals 24. And then I divide by the number in front of x, and I get x equals 24 over 48, which if you type into your calculator is 1/2. So x equals 1/2. But I don't care what x equals, I've got to plug it back in. Y equals, and it doesn't matter which one you plug it into. I like to plug it into the one that already has y by itself. 8x minus 1. 4 minus 1 is 3. So these lines intersect at the point 1/2, comma 3. That's where these two lines intersect. One more. Y equals 5x minus 1, and 10x equals 2y plus 2. All right, so y is all by itself. I'm going to pick this up and plug it in. Wherever I see a y, that's what I'm replacing it with. Y got replaced with 5x minus 1 there. And now we solve. I've got a little distributing to do. Everyone's second favorite property. All right, those add to 0, so I get 10x equals 10x. Well, this is the same thing on both sides. When I have something equals something else, when I have chicken nugget, when I have one thing on this side equals the same thing on that side, that tells me there's infinitely many solutions. Because I can't spell infinitely. Infinitely many. I don't think that E is supposed to be there. Let's get rid of that E. Infinitely many. There we go. Many solutions. Just like when we solved equations in the beginning of the year, if you have the same thing on both sides, you have infinitely many solutions. All right, so hopefully this was a good review of 8th grade last year, and let's do a little word problem to end this lesson here. So an animal shelter spends $2.35 per day. Each day it costs them $2.35 to care for a cat, and $5.50 per day to care for a dog. Pat noticed that he spent a total of $89.50 for cats and dogs. So I'm dealing with money here. So here's what we do. We put the money together. $2.35 for every cat. That tells me to multiply them. For each is a multiplying word. And if I add that to $5.50 per dog, Together, that gives me my total of $89.50. Notice I've got money, money, money. Everything in this equation has to deal with money. So the price per cat, the price per dog gives me the total. So this is not a system, this is just an equation. Because I only have one of them, it's not a system. Pat said there might have been 8 cats and 14 dogs. Is he right? Well, I don't know. Let's check. Let's plug it in. Does this make my equation true? Is 814 a solution to this equation? All I have to do here is type this on into a calculator. So on your calculator now, all you have to do is see what you get. So 235 times 8 plus 550 times 14, and I got 9580. Does that equal 8950? Oh, look how all those numbers are basically the same, but they are not equal. So is Pat correct? No. There's not 8 cats and 14 dogs at this shelter. We don't know how many there are, but it's not that. Later, Pat found a record showing there was a total of 22 cats and dogs. So let's write a new equation. This equation has nothing to do with money. It just says cats and dogs, when I add them together, gives me 22. So that's my new equation. This is what I refer to as a total equation. And this equation up here refers to a money equation. Why? Every number you see here has to deal with money. And here, the sum, the total, equals 22. The cats and dogs, the number of cats and the number of dogs gives me 22. So now we have a system of equations. We have this system of equations here, 235C plus 550D equals 8950. And I also have C plus D equals 22. So using substitution here, I've got to find someone that's all by themselves. And I don't see that, right? So watch what I'm going to do. Here's C. How do I get C by itself? Well, I'm going to move that D over. I'm going to subtract D from both sides. So that gives me 22 minus D. That's now all by itself, so now I can substitute. Wherever I see a cat, I can replace it with 22 minus dogs. So there's my substitution there. And this equation just looks messy because of all the decimals. 2.35C cats plus 550 dogs equals 8950. So now I have an equation with just one variable because I did that substitution. So sometimes you've got to kick a variable over to the other side through subtraction to actually do substitution here. So now I'm going to distribute. I'm going to pull out my calculator here so I don't make any arithmetic mistakes. 5170 minus 235D plus 550D equals 8950. This problem's not scarier, there's just decimals that make it annoying. So I have 550 minus 235. 550 minus 235. 550, which I should be able to do in my head, as should you, but I'm going to be lazy. I want to get that D by itself, so I'm going to move over this 51.70. And again, there's crazy decimals, so I'm using my calculator. 8950 minus 51.70. And here's the moment of truth. When I finish solving here by dividing by 3.15, we get D equals 12. But we're not done solving the system. That's dogs. Dogs is 12. Well, and if you think about it, there's 22 total. 12 of them are dogs, so cats are 10. So there's 10 cats and 12 dogs. That's the magic number of animals at the shelter. Okay? And finally, we're not going to solve this one, but let's think about this. Why is substitution no good here? Well, to use substitution, you want one of the variables to be all by itself. I've got 3x, 5. No one's all by itself, and you have these crazy numbers in front of them. So this would be a mess to do by substitution. It can be done, it's just messy. So you would have to get one of these variables by itself, then you'd have to divide, and there'd be fractions, and it would be hideous. It would be terrible. So let's not do that. Let's save this. This one we'd actually solve with elimination here, which we're going to talk about later in the week. So solve it using substitution? No. This is not one you solve using substitution. We only like using substitution when one of our variables, doesn't matter if it's x or y, when one of our variables is all by itself.